Hello. Welcome back to Networks and Cybersecurity. Today we're going to review the most difficult homework, I think, so far. The sixth one, the compressing your network traffic from homework 5 so that you can support multiple clients. And while I get ready here, I'm going to ask you guys to open the VM and I'll give you my IP and we'll see how improved the new version is. So the solution is up on Canvas. You can go ahead and load it in if you want to follow along, and then we will see how much better our speed is on the VM. Okay, without further ado, let's get started. I am going to go to the full screen today so that you guys can get a better picture because I think there's a lot of code to look at. So I think you're going to want to see the whole screen rather than looking at my face. So the first thing I'm going to do is copy the contents of homework 5. Actually, I already did this. So I've copied the solution to homework 5 and I'm going to use that as my starting point. A lot of people decided to try to make do with their homework 5 where they had not completed the bonus, and they found that there's a reason that the bonus was difficult. That it's pretty hard to get that talk back of the entire game state going. That's why I put together sort of this solution so that you could see at least a minimal example of that running. Now the only change I've made here from what I submitted is that I fixed a bug. Remember, there was only one size for all the clients in the version that you had for the solution. So I fixed that by simply adding the size as a field to all the TCP workers. And so now they update their own size when they get it. They don't update the game's size anymore. So I commented out this line and just changed it to that. And this is basically the only difference. So when game receives a point, it uses this receive point XY color size method. All right, so the first thing I'm going to do is actually going to be the last requirement. Let me make all my font bigger. Let me know if that is not legible for anybody. I can always go even larger. Okay, so the first thing I'm going to do is the last requirement, 10.1. I thought this was probably the easiest, which is converting it so that instead of sending a XY coordinate and then processing at the server's end, we send the row and column. And then the server just decides where it's supposed to go and how big the drawing is supposed to be and everything. So there's a lot of advantage in doing it this way. The biggest advantage is obviously that we don't have to do all of the computation for where points go on the server side, which frees up a little bit of the server's resources. The client decides where the point is actually located. This might come into play on the next assignment, though. Think about how this might create a vulnerability, because your next assignment is going to be to write a client for this application that cheats. So basically a client for this application that, if this were a competitive game where the goal was to get as much of the screen in your color as possible, the client that you would write would win at it every time because your client cheats. So you would, without being able to change the server at all, assuming that the server is the way it is at the end of this solution we follow along with, you are going to try to cheat. All right, so we need to convert it to take row and column instead. So the first thing I'm going to do is change it so that it doesn't take a point. It takes an X and Y location, and that is going to be the row and the column. Now they're going to be encoded the same way. It's still going to start with A. There's still going to be those next three and the next three numbers. I'm still going to hopefully have those leading zeros. I'm going to see if I can figure out how to keep the leading zero, so I don't have to change anything there. Obviously, this is going to make me update the receive point method. So let's go in there and see how I can update this to support a already specified row and column position instead of finding where that XY coordinate is and specifying it. So It's actually fairly simple. I have this code up here that loops through all of the rows and columns, all the grid units, figures out if one contains the point, and then does everything it's supposed to do on the one that it finds. So essentially I'm just removing these three loops here. I'm actually going to copy them because I might need them later. But I'm removing those, and I'm removing their three closing curly brackets. And let me scoot all this over. And now I just need to change it to take row and column instead of a point, and that should be good enough for me. All right, so now I'm taking row and column. And of course, every time you do something like this, you want to update your documentation. So this now takes a row and a column. I wasn't too harsh on people who didn't do this. I was mostly looking at your documentation on your new stuff. But this receives now a row column address over the wire and draws around it as applicable. That solves everything on the receiving end, actually. So we're now receiving a row and column address. We're drawing it where it's supposed to. But remember that on the sending end, we're still sending a point instead of an X and Y, a row and column. So we need to go and update the sending end in order to send a row and column address instead of a X and Y coordinates. So where would I find it on the sending end? It actually took me a while to remember where I put it. I actually put it on color grid because it's part of the UI. So what happens is that when the mouse is dragged, it starts to transmit the X and Y coordinate. And we have some formatting here already to get it into that 3-digit number with the leading zeros. So let's see that if I can continue to do it that way. So I remember I copied this. I'm going to need it again. And I'm going to look for it, and then we're going to fix it. All right, so to fix it, I need to know how many rows there are and how many columns there are. I actually have access to both of these variables because color grid has a reference to the game. So these are actually game.rows and game.columns. That's how many rows and columns are in the game. I specify it at the top of this class. It's one of its field variables, so you have access to that. And then I want to see if the row column in game contains that point. Well, again, I have access to the grid through that game reference. Now I don't have a P, I have this point. P was supposed to be a point in the original. So remember, the receive method here took a point as an argument before. That was the P. But the point that it actually used to take was this one, the one that it was getting from the X and Y location here. So I actually just want to get the point from here, from the mouse event directly. Okay, and after I have found the unit that contains that point, I am going to need to send, rather than the X and Y location, the row and column location. So I'm going to change this to send the row and the col instead, and without changing the format, it's still going to transmit those leading zeros. So at this point, I'm going to go back and make sure that it works as intended. All right, so far I can draw, but let's see if the big improvement is available, that if I make the screen bigger, I can still draw, and I can. And so I've solved the problem of not being able to draw to differently sized screens. It now correctly scales the pixels and draws the kind of scaled image you intend. So that's great. Let me just take this opportunity to demonstrate how great it is. It's a big old smiley face. Lovely. Okay, so that part's done. That netted you at 10 points if you did it. Now the next part is, again, I'm going to go backwards and I'm going to do the server's info panel. So there were a lot of ways to do this. I think the easiest way was just to go through and make a new class that's your info panel and then link it to everywhere where it needed to be linked. So add it as a reference to all those different places. And that's probably the way that we've usually learned it. And I saw a couple people do something I didn't think of, which was really clever, which was just maintaining a list or an array list of all the TCP workers. And you could have done this in server. Every time a TCP worker is made, you could have added them to the list, because in this implementation, the TCP worker actually has all the info you're looking for. It has color, it has size, so all you needed to do from there is figure out how to read that stuff out. But that didn't occur to me, so I'm going to do it the way that I thought would be the easiest to do. I actually, in retrospect, think that the way that a lot of you did it, where you made a list of workers, is probably the easiest way to do it. So if you did that, I would stick with it. But I thought, okay, I'm going to make a class that maintains all of this information, and I'm going to make it a singleton so that anybody can access it lazily without me having to update all of the references, and then I am going to have the workers update it as needed when they receive a color or a point, and the server register people as needed. So the biggest advantage to a singleton when you have a relatively large program like this with, what do we got here, 8, 9, 10 classes or something, right? Biggest advantage to a singleton is that everybody can refer to the instance whenever they want, and you don't need to create references to it, which is definitely very lazy, but it is an advantage nonetheless. So I'm going to call my singleton server info display, and you'll see me looking over at my reference for a while because I can't do this from memory. This is a pretty complicated one. I'm going to display that this is a singleton, a singleton that manages a display with all the connected clients, their colors, and their size. That's going to tell me the intent here, because I know that I'm going to do that when I write it. I like to write my intent when I have a class in mind, and I already have a class sort of structure that I'm thinking about. So a lot of you, I've noticed, tend to write the comments at the very end, I would say. Not a great idea. You should write them as you go. What am I doing here? Extends jpanel. Did I forget to import something? Or did I spell jpanel wrong? What do you got? No suggestions. Was my autocorrect broken? No, it was. That's weird. That doesn't happen too often. Okay. Well, you can tell that I'm the kind of programmer that needs their autocorrect to keep going. And there's definitely a debate, by the way, about that, about whether it's good to be the kind of programmer that needs one or the kind of programmer that shouldn't. And in my opinion, if you are memorizing all your different import statements and all the different classes you need, you're wasting a lot of your mental bandwidth. I prefer to use the autocompletes whenever I can, just so that I can focus on big picture stuff. But the opposite camp definitely exists. A lot of people advocate not even using an IDE, so you don't get any kind of autocompletes of any kind. So definitely plenty of people in that camp too. Alright, so for it to be a singleton, it's going to need an instance of itself. If you haven't used this model before, if you haven't taken design patterns, which most of you haven't, singleton is a class that only has one instance of it at any given time, generally speaking. So you just have one instance of server info running for your whole program, which means that this is a class that you expect is only going to have one copy of it across the whole program. And this instance is accessible in a static way, so any of the other classes can always access the running instance of this object whenever they want. And this is a helpful pattern for a lot of reasons. So I'll set up the constructor first, just blank for now, and then I'll go back to it in a bit. Well, actually, let me specify the values that I think I'm going to need. I'll probably take a width, height, and a background color like I always do. And then I will probably go ahead and just copy those, the initialization stuff from any of the panel initialization stuff that I tend to have in the driver. So I'm going to probably have some of this frame stuff in there, and then I'm also going to have the panel instantiation stuff in there too. So I'm going to do both of those things in the constructor. I'm not going to have the frame built in the driver. And this is because it's, again, a singleton pattern, so nobody should be able to instantiate this object. It should only instantiate itself whenever somebody tries to get an instance of it and one doesn't exist yet. So remember, there's only one instance of it at a time. If somebody tries to find that instance, get it, and there isn't one yet, so no one's made this object yet, it just makes a new one of itself and returns that. So there's basically always one in circulation at any given time. Alright, so this I'm just going to refactor to a different name because this isn't a picker frame. I'm going to call this an info frame. And we're going to add itself rather than color picker panel. And I will change the name of it to server info. And I'm going to put its location. I think this is a good location. Let me go back and see where the server's at. I just manually coded these in. Obviously not best practices, but I didn't want to do the whole toolkit thing and scale it to the screen. That's certainly something that we should do later if we're going to improve this. For now, I just wanted to do it manually. I know the server is 400 by 400. It starts at 600, 150. I'm going to make this 400 by 400 too and start at 200, 150, so they start next to each other. I think for testing, it's actually a good idea often to hard code your locations because you end up being able to see everything. A lot of people did not take their locations into consideration. And when I start the server and then I start the client, they're on top of each other. Or when I start the server, both of its screens are on top of each other. When I start the client, both of its screens are on top of each other. Yeah, that's annoying to me as the person who's grading and testing it, but it's really most annoying to you because during development, every time you run it, you've got to move your stuff to test it every single time. That's your own time that you're taking there. So just make sure that at least during the testing phase, you put some thought into your location so that they start apart. Okay, now we've got the constructor. I'm going to move on to the singleton part. So if you've used this pattern before, this will be familiar to you. If not, it's a little bit weird. So everybody can access, again, the single running instance of this class by using the getInstance method, which is public and static. So there is ever only, again, one copy. And you are going to return this instance here. And again, if one is not currently running, so if one doesn't exist yet, which is true at the beginning of this class because we haven't instantiated instance yet, then it's going to create itself. And again, I said it'd be 400 by 400. I'm going to make it white. You'll see in the solution that I added utility methods to change the color and location, just in case that we're going to do this down the road. This would probably be something you do. In driver, you would actually update the location and the color from there. So this would just be like a temporary when it's first instantiated. And then we're going to return the instance if we've made a new one. And if we already have one, so if one already exists, then we're just going to return it. So again, a very confusing pattern if you haven't seen it before. But all you have to really remember is that where you've got kind of a static context here, there's only ever one copy of the server info display in existence, and anybody can get it by calling server info display.getInstance. Okay, so now we need our information, our stuff that we're going to have for the different users when they connect. So I thought that the best way to do this would be to have a list of the IP addresses and then a couple of other data structures to hold the other things. A lot of people manage to squeeze all three of those pieces of info, the IP, the color, and the size, into one data structure, so into some kind of list of sorts. Or I saw a few multi-dimensional arrays, so people made an array with a few columns. One column was the address, one column was the color, one column was the size. The hardest part about doing it all in one data structure is that you have three different data types. You have a string, a color, and an integer. So that's a little bit difficult. But if you wanted to squeeze it in that way, you certainly could. I thought that it would be better to have everything refer back to the IP address. Now, if you haven't taken 328 yet, some of this stuff might be confusing to you. I will try to do a high-level summary as we go. First thing everybody should be familiar with is array list. So an array list is essentially an array where you don't have to worry about the length, right, because it grows for you automatically. So I'm going to have to import array list as well as inet address here. And this will just be a list of all the IP addresses that have connected. All right. Now, how should I store the color and the sizes? So the important things here are that I can place new colors and sizes into this data structure in constant time. So when somebody connects, I don't have to go through and search for their address. It just goes in quickly. And then also, when I go back to refer to the color and size of a particular user, I can access it quickly. So it accesses in constant time too. Both of these things scream hash map to me because hash maps can place and access in constant time. I will actually never have to iterate through these as long as I have the user's array to iterate through. So the downsides to hash map don't apply here. It's basically all pros. Now if you haven't used hash map yet, if you haven't taken it in 328, a hash map binds a input key to a output value, basically. So when you feed it the key, it gives you back the value, and it gives you back the value using some magic that we won't go into in constant time. So very quickly, even if there are a million entries in the hash map, it will give it back to you in the same amount of time, essentially, as if there were only 5 entries in the hash map. This makes them excellent for situations where you just want to see if a key exists inside of this data structure, or if you want to get the value quickly. There are other downsides, like I mentioned, but none of them apply here. So I'm going to bind address to color. Now, why have I made this public here? Why did I make this public? Or private, sorry. Why did I make it private? So I made it private because I don't want other classes to access either of these elements directly. In fact, this should probably be private too. I don't want any other classes to be able to register their own stuff into any of these data structures unless I let them do it through the server info displays many methods, which we will make later. Otherwise, I find that it gets even more confusing. So our size will be a inet address bound to an integer. Okay. And then the last thing we're going to need is the keyframe size, which is common to all of the clients. Some people gave everybody their own keyframe size. Technically, each TCP worker does compute it independently, but it should be shared by all of the different workers. They actually all should get roughly the same answer, unless they're slightly out of sync and they get the game state at slightly different moments. Then there might be very minor differences, but for the most part, the keyframe size is almost the same for all of them. And then for that total bandwidth, I'm just going to count how many users I have and multiply by that keyframe size, because remember I said that you could do that as a simple way of getting it. Okay, so next I need to paint all this information to the panel. So let me copy a paint component method from somewhere so I don't have to rewrite it. Here we go, I'll just copy up to there. And then add the semicolon in myself. Or add the curly bracket in myself. Alright, great, I've got a paint component method here. So I want to print all of the different pieces of information here. First I'm going to change the font to something cool and also something that is monospace so I can better determine the amount of space that each thing takes up and size my thing appropriately. So I'm going to go plain font and size 14. Again, this should really be scaled to the user's screen. 14-point font is microbial on like a 4K display, but it's going to be fine here. Okay, and I am going to loop through all of the different addresses and draw them all to the screen. I could use a label here, but I'm going to be especially lazy, and I'm just going to use g.drawString, which is just the easiest and laziest way to draw a string of information to the screen. What did I call it? Users. So I'm going to loop through all of the different users, and I'm going to draw them. Now, instead of displaying their color, which most people did, come on, that's boring. I'm going to take advantage of the fact that color is colorful, and I'm going to actually just draw their thing in the color that they are, right? So I'm going to extract their color that they've currently chosen, and I'm going to draw their display in that color instead of drawing it in just black and printing their color. I think that's much cooler. Okay, so I'm going to draw the string, and I want to get first the address itself, right? So I'm going to convert the address to a string and print it, and I keep spelling it wrong. Okay, I'm going to move the x and y coordinate aside for now. We'll deal with that in a bit. So I'm going to do first their address, And then I've already displayed the color by making the string the color that they've chosen, so I don't have to display that. But I do still have to display size, so I'm going to display size there, and that's going to be sizes.get their address. So getting it out of the other hash map there. Little colon. So that prints out the IP and the address. Now I have to deal with how I'm going to place these on the screen. So first I'll give them a little offset from the side. I'll call that the start. This is going to be how far they start from the left and the top of the screen, so they're not just smushed right up against it. Then I'm going to determine how much spacing they need between different entries. A little bit of trial and error here. I figured out 25 was a good number, but again, this really should scale to the screen, and all of this could have been avoided if I had just used a JLabel, but again, I got lazy and decided to draw the string. So if you want to convert it to the JLabel, more power to you. And then I'm going to use a counter to see how many I have written so far. I'll use this later to compute the keyframe as well. So the X location is going to be the same for all of them. They all start on that left side of the screen. And then the Y location is going to be the start plus the spacing times how many entries we've got so far. All right. And every time we gain a new entry, I am going to say entries plus plus so that we can keep track of how many there are overall. All right, that handles the drawing of the user information. Now let's also draw the keyframes. So for this, I'm going to draw a separate string, and I'm going to call this key size. I'll say in bytes. Let's just say byte for brevity. Again, I'll get rid of the X and Y and deal with those later. A key size in byte plus the keyframe size that we specified up there. Notice I haven't actually linked any of these in yet, so that's going to come way later. And then the net size, okay, and that's going to be plus, I like to have my pluses on the previous line so it's clear. That's going to be this is going to be a math formula, right? We're going to have the keyframe size times how many people have connected. And let's say I want to do it per second. I want to see how many bytes are coming out per second. So in that case, it would be times the tick rate. You can get the tick rate from the TCP worker. Remember, we get a certain number of key transmissions per second. I think the default is 32. And so this gives you the total number of bytes per second that are coming in. All right, the X start location is the same, and the Y start location is also actually the same, because remember we have that entries plus plus. This will just go at the end of everybody's entries. Okay, and I am going to also make sure that this gets drawn in black instead of in the last color that a user picked, just for usability, for drawability's sake. So that handles the drawing of all the different information I wanted. Now I don't have any kind of repaint yet. I don't have any kind of repaint. So I'm going to make this automatically repaint every second so I don't have to worry about doing it later. And the best way to do that is, of course, with a thread. I'm going to use the runnable version because that is my preference when it is available. And we are going to close it up and do the dot start. And there we go. So now we're set for a run method that automatically repaints the screen. So I could just do this. That would be the laziest way to do it. This would repaint as fast as possible. I'm going to make it just slightly more complicated and have it repaint only once every second or so to save resources. Again, this happens on the server side, so we don't want to be too fast and loose with the server's resources. We don't want it to spend all of its energy constantly repainting itself, so instead it's just going to repaint once a second. It'll sleep for a second every time it finishes a repaint. This also reduces the likelihood of a threading issue because it only tries to access those variables once a second. All right, anything else we ought to do here? So another thing that I did in the solution was I proactively decided that I was going to try to avoid any kind of threading problems by putting all of this in a try and catch. You don't have to do that, obviously, but if it's all inside of a try and catch and you run into any issues trying to access any of this stuff, it'll just deal with it and move on. Because next time the repaint happens, hopefully you don't get that same issue. So basically, if anything goes wrong during the collection of the data, I want to ignore it because it's just going to repaint itself again in a second, and any mistakes that happened will be erased. I could say like that there's probably a threading fault happening here. I think that's what I did. Probable thread faults. Otherwise, you don't have to. Okay, let's get everything to draw before we move on to actually linking it to the information. So I thought that in order to have the instance available as soon as possible, I would have it just get built in the driver. You don't have to do this. It'll get built whenever somebody first needs it. But if I do serverinfo.getInstance here, remember if it doesn't exist, it will build itself. And so here is my lovely server info panel complete with its key size. Of course, right now it doesn't do anything, so if you connect and draw some stuff, I haven't actually linked anything to it, so it just sits there with its 0 forever. Okay, so now let's see how easy it is to link stuff to a singleton. So you don't have to worry about passing references. You don't have to worry about going back to your driver or anything like that. When you want to register a new worker, so this is in the server here, all I have to do is call the info displays get instance method to find the actively running server info panel, and then I just have to register this person. So I don't have that functionality yet. Well, let's go back and add it. So I need the functionality to register people, update their color, and update their size. So first we'll go with register. Registering a user in this case is very simple, but we do need a few pieces of information. We need their address, we need their color, and we need their size in order to properly register them. Oops, didn't give it a name. Okay, so we're going to add them to the array list, and then we are going to place their links between their address and their values into the colors array. So that's going to be put, is what you use for maps in order to put information in them. So put. And likewise for the size, we're going to put that in the other hash map. So we put the color, put the size. Okay, that registers a new user. Registers a new IP address to be monitored on this panel. Okay, we're gonna do a simple thing for updating the color as well, where you just have to, in a hash map, use put again. You don't actually have to go back through the hash map and find their location or anything like that. If you do a put on a key that already exists, it simply overrides it. So this is another really convenient feature of hash maps for this application, is that we don't have to find where they are in the hash map again. We simply override their entry by just doing the same thing. So updating color is dead simple. Likewise for updating size, we don't have to find their size entry, but we just have to do another put, and lo and behold, it is updated. So sizes.put, and you're done. Very simple. Okay, I'm also going to do one for the keyframe. Okay, so we did need to update the keyframe. Here again, I'm going to do something that's a little bit premature. I'm going to try to make this thread safe. This might not be a good idea because it might actually slow down the application as many workers compete for getting this spot. But I'm going to give it a go and see if there's any performance issues. I don't think so. Or let's omit it and see if there are any threading performance issues. We can do that too. This is going to update the keyframe to some size. So we take an integer here. And there we go. That updates the size of the keyframe. So why make it synchronized potentially? Because if multiple different workers try to update it at the same time, you could run into a threading issue potentially. If this is a threading issue that's kind of ephemeral, you probably won't notice because the next worker will just update it and everything will be fine. So in this case, it might be better to just deal with the errors rather than preventing them. Okay, so now we can register people through our instance. Did I save this thing yet? Let's see. Yep. Okay, so now I should be able to register users. Oops. What did I do here? I've got private static server info display. Server info display get instance. Okay. And let me just retype this and see if my autocorrect just decided to go away for a bit there. So get instance dot register. Oh, there it is. Register user. I don't know how I didn't catch that. Okay. Register user. So there are a couple other register type methods that it inherits from JPanel that I got a little bit confused by there. So we're registering the user as they come in on the server, so as we create their worker. So I want their inet address. I can get that from socket.inet address. As we got it here, we got accepting connection from, well, that's going to be the IP address of that person. And then I'm going to basically use a temporary color and size, because when you first connect, you probably don't have your accurate color and size. You have whatever the default is in the TCP worker, right? It defaults to black and 1. So these are going to be updated as soon as they finish updating on the server, and these are going to be updated anyway. So this is fine. But I've registered them with that address, that color, and that size. We need to have their entries in the hash map because I don't want to see nulls in the display when I look at it. All right, so the next change is going to be to go and find where in the TCP worker color and size get updated on the receiving end. So they get updated over here. When you get an S, that updates the size. So I'm going to add, again, without having to add any kind of references, all you need to do is access the instance, and I'm going to update the size of this user. So I need their inet address. Again, I can get that from socket.getInet address. Every TCP worker has the socket that they use. So I get that from socket.getInet address, and then I'm going to just specify the size that I got there. I'm going to use this .size, which is the accurate one because it's actually 1 smaller. The size of 0 is displayed as a 1. It's just a little quirk I inherited from doing it that way. And same thing for the color. Again, I don't have to do any referencing. I just access the one instance of it, and I can update the color. I'm going to use the inet address again. And don't buy Razer keyboards. And the color. All right. So that is my info panel. Well, let's see how it works. Launch it. Connect to it. Draw some stuff in blue. I got nothing. Uh-oh. Is it repainting? So it looks like I forgot to repaint, didn't I? And where did I forget to repaint? Well, it looks like there's a repaint here, right? So what is the issue? Why did it end up not actually repainting itself? Well, because I forgot to put it in a while loop, right? It just repaints the one time when it starts. Womp womp, stupid mistake. It took me a while to diagnose that the first time I made it too. All right, let's go for the client again, and let's look at the info again, and there we go. There's my IP address. I've got my size. So let's say I update it. Now remember, it refreshes once every second, so it can take some time. Let's see if this turns my text red, and it does. I go back to 0, I get a size of 0, I go back to 1, I get a size of 1. All right, now I need to update that keyframe size as well. So that's something that, again, we have access to in the TCP worker. Now this one I did kind of lazily because there are actually lots of workers under the server's control. And so it's probably better if all of them don't update the info display. So this might be something that I would figure out later, just to not have all of them competing for updating it. There's really no particular reason that they should all do so, but it was much easier to just say server info get instance and update the keyframe here, even though, again, you're looking at lots of different workers updating it at the same time. Now, I don't want to have to serialize the game twice. That's kind of annoying. So I am going to end up putting this into a byte array. We haven't quite gotten to that point because we haven't modified the keyframe yet. So I'm just going to comment this out and get back to this because we're going to modify the keyframe first, and then I'll figure out how actually big it is. So insert the actual size of the keyframe, and I'll just delete this so that it gives me an error. Alright, so that brings us to the keyframe, the hardest part of the whole thing. This will probably bleed into the next class a little bit, the discussion of how to do the keyframe. So that all went back to this complicated object out dot write object serialize the game method that I wrote, and then also on the client end in the receiving portion you had, we take a 2D array of colors in from the read object, and then we deserialize it. And those two methods are both part of the grid game manager. Okay, so I am going to change these completely. I am going to get rid of the serialization entirely, because no matter how good you do, if you're sending an object, you're still incurring a lot of overhead for this serialization. You've still got that java.lang.number stuff at the beginning. You've got extra little bytes used for telling Java how the array is structured. If you're sending objects, you're sending a lot of their extra baggage. Like if you're sending an array list, it might also send fields like its size and stuff like that, which you obviously don't particularly need to send. So the best and purest way in order to get your size down as small as possible, and on this I'm going to try to demonstrate the minimal size possible, is to send just an array of bytes. So a raw and a pure array of bytes. We've been sending arrays of bytes in different ways since the beginning, right? We've been sending our strings, for example, as arrays of bytes and then extracting them at the other end, but we've never sent anything this complicated as an array of bytes, which is where a lot of people had their tripping point. And I think that many people tried to stick with the serialization and succeeded. People definitely got in the 3,000, 4,000 range with serialized objects that were just very nicely compressed. So it wasn't impossible to complete this with serialized objects too. Actually, if you just followed these slides and did the repeating trick with a serialized array of shorts, instead of ints, then you probably would have gotten really close. If you did it with ints, you'd probably be in about the 400 range, and if you did it with bytes, the 4,000 range, and if you did it with bytes, you'd probably be in like the 2,000 range. So it's actually not that bad. The overhead of serialization is not that bad when you have a very large array of stuff. It only starts to become, like, for example, when you're sending the integer in Wireshark, the overhead of serializing an integer is something like 90%, right? The stuff that came before the actual value of the integer was like 30 bytes, and the integer itself was only like 4 bytes. So most of that was lost to overhead. When you've got a bigger array, a little bit less to overhead. But nonetheless, the best solution was just to send some raw bytes out. So I'm going to modify everything to send out raw bytes. Okay, so getting rid of the loop here. Let's call this as bytes first. We're actually going to make a couple of conversions on our way. And how many bytes do we need to store the entire game state originally? Well, if you need 3 bytes per cell, and you should be able to easily tell that you need 3 bytes per cell because each cell contains just a color. That's the only relevant information there. And as I hinted a few times on Discord and in class, each color can be stored in a single byte. 0 to 255 is enough for a color. So the most that we're going to need is how many rows we've got times how many columns we've got. So the size of the grid, and then times the number of bytes per cell, which is going to be a 3. I'll just put some parentheses around this because I like parentheses for math. Alright, so that's going to be our, let's go like that. That way it's obvious that it's the size of the grid. That's going to be the size of our byte array before any kind of compression. So that's just going to be what we do first. We're going to move all of the colors into a one-dimensional byte array. This was really complicated for a lot of people. If this is something that's tough for you to conceptualize, I encourage you to split it into a couple steps. So take your two-dimensional color array, turn it into a one-dimensional color array, then turn it into a byte array. I'm going to do both of those things in one step using the power of math here. So we're going to loop through all of the different values. Whoops. Get back there. Where was I? There I am. Ah! Stop it. Stop it, Eclipse. No! I got myself trapped in click mode. Alright. Okay. Alright, so that loops through all of the different values, and now I need to determine, so for a particular color in a particular spot, where is it going to go in the byte array? And the best way to do this is to think about it mathematically. Alright, so the color at 0, 0, that's going to end up going to spots 0, 1, and 2 in the byte array. That's pretty obvious because it is going to go to the first 3 spots, and it's going to require 3 bytes for it to go in there, right? So that's going to be the first byte holds its red, the second byte holds its green, and the third byte holds its blue. Okay, and this is the color at 0, 0. So the color at 0, 1 is going to go to 3, 4, 5, and the color at 0, 2 is going to go to 6, 7, 8, and so forth. And so the formula here is pretty simple. If you want to get which cell will be the red one, well, that's pretty obvious. It's just the column that you're on, so this value here, the column, and then times the number of bytes per cell, so the bytes per cell field there. Okay, so that's pretty easy, but how about when you get to the end of a row, right? So how many bytes does a row occupy? Well, if a column occupies 3 bytes, a row is made up of so many columns, then the number of bytes to make a row is going to be the number of bytes per cell times how many rows you have so far, so times the row, and then times the max columns, because we are a complete row is made up of the max number of columns. So in this case it's 50 by 50. So if you're looking at where the first cell in row 1 is, it's going to be the number of bytes in a cell times that row number, which is 1, and then times the 50 columns that you've had previously. Okay, so if you put these two things together, this is 3, by the way, so maybe it's simpler if I just say 3 here. If you put these two things together, then you get the final formula, which is the two of these combined. So that is the 3 times the row times the max columns, and then plus the column times 3. That tells you the address of the cell in the one-dimensional array that you are targeting for your byte storage. So final formula looks like that. All right, so I'm going to make this value as base index. That's what I'm going to call it. So that's going to be the bytes per cell times the row that we're currently in. Again, I want times the maximum number of columns. I have that saved as calls. Remember, that's comes from here, comes from at the top. That's the number of columns in the grid. I always want to refer back to this because my plan for the future is just to be able to update that number. So if you said 50, that was a bad thing to do. You should go back and make sure it's not hard-coded. Okay, so bytes per cell here times, and then the column that we're currently on. So that gives you the base, right? That gives you the address of the red, the first byte. And then obviously the green is just +1, and the blue is +2. So once you have the red, you of course know where the green and the blue are. Okay, so now moving the colors into that one-dimensional array, I guess we will pick that up next time, and then we will see how to compress this whole thing down as small as we possibly can. I will put the second homework up at some point later today. Again, you are going to be cheating and trying to trick the server into being all your color. And I will see you guys Friday. Okay, adios.